Hi everyone, this is Angela Bhatia along with my group partners Arbit Devendra Bhai Patel and Mohammad Saji Doctor. So we are going to do the presentation on fuzzy based power management of the wind power plant, and this project is under the supervision of Dr. Moshin Jamil. So these are the table of contents for our presentation. First, we are going to do some introduction of wind power plant, then some literature review, the power management in wind farm, physiologic control, and how we are doing the wind turbine control using the fuzzy base. Then we are going to talk about the performance comparison using the PID as well as the fuzzy control. Then the result analysis that we got from this project, lastly the conclusion, and lastly the question and answer session. So moving on to the first slide, which is introduction to wind power plant. But before that, let's get a brief overview of the wind energy and its importance. So we all know that wind energy is the most cleanest form of renewable energy that can be harnessed from the wind's kinetic energy. And uh, from a past few years, we already know that wind energy has gained an importance in global quest because of its sustainability and for the global energy solution also. And it is a crucial component of energy transition because it's reducing our reliability on the fossil fuels. There are certain fundamental components of the wind power plant, like wind turbine, which will convert uh, wind energy to a mechanical energy, a rotor blade which will help to capture the wind energy, nickel which contains the control system, gearbox, and the generator which will again help us to convert the mechanical energy derived from the wind turbine to an electrical energy fed to the grid, tower which is used for the support system of the wind turbine, and the control system which is the most important part that will help us to monitor as well as optimize the performance of the wind turbine. So whenever we talk about some system or the power plants, we know there are certain advantages and some challenges. But in wind turbine, the advantage is that because it creates no greenhouse gas emissions, so it will reduce the carbon footprint which we are now moving towards, and it will also mitigate the climate change. But some challenges is that wind turbine, like wind energy, is not stable. It always varies with the time, so whenever there is a sudden change in the wind power output, it will affect the grid stability. So that's why we require an management technique to create an advanced grid. So that's why we require power management for the wind power plant. So let's talk about the power management in the wind farm, why it is important, because it will help the wind farm to maximize the wind energy utilization as well as the grid integration in the wind farm. So in our project, we have used the fuzzy logic control that will help us to do the power management, because some, like the traditional methods like the pitch control or the PID control, have some limitations while managing the wind farm. And fuzzy logic based power management is also an attractive and the promising solution, because using this control we can achieve higher stability, efficiency, as well as the reliability in power generation. So from this figure we can see that the wind power passes through the turbine, converts it into mechanical power, and that mechanical power is converted into electrical power which is fed to the grid. And in this whole process, we from the turbine to the power interface, there is a control system which will help us to manage the wind farm, and that control system in our project is the fuzzy logic control. So the next slide will be continued by my friend Arpit.
Hello guys, my name is Arbit Patel and today I'm going to explain you about the fuzzy logic control. So it is a powerful tool for managing uncertainty and imprecision in the control systems, and representing and processing linguistic variables offers a more human-like approach in the decision making. Fuzzy logic is a type of, you can say that it's a control system that it has a good adaptability, it is robustness and transparency make it a valuable technique for various real world applications. So basically, the fuzzy logic which we have used in our project is for the power system applications, especially in the wind power generation. So it is a type of control system, you can say, which takes more of a human-like decision, uh, and the membership function assigns a value between 0 and 1, indicating the degree of membership, where a 0 represents the non-membership and 1 represents the full membership. So FLC involves using membership functions to determine the degree of membership of an input value to a specific set or category. So basically here you can see the fuzzy logic block diagram, where the input is applied to the fuzzifier, and then it is processed based on the rules, and then in the inference engine, and then in the defuzzifier it is processed to get the output decision. So fuzzy logic control basically is used to enhance the performance, efficiency, and safety of the operation of a wind turbine, and to get the maximum power output from the arrangement of the wind turbine. So basically fuzzy logic controller takes the inputs of the set number of powers, frequency, and right, it also adjusts the turbine's pitch angle and the rotational speed in response to the real-time wind conditions, and then the output that is generated from the fuzzy logic controller, it maximizes the power output. So this is the adaptive approach which enhances the turbine efficiency, increases energy production, and reduces mechanical stress on the system. As you can see in the block diagram, that how fuzzy logic controller takes the inputs of the various parameters, and then it is given to the wind turbine and then generator, and ultimately we get the maximum possible power output in our power system. So here in the fuzzy based wind turbine control, the fuzzy logic controller was initially like proposed to replace the conventional PI controller to reduce the error. Here fuzzy logic controller has an advantage over the conventional PI controllers. So basically it has a more efficient performance as compared to other controllers. As you can see here in the fuzzy logic controller diagram, which is a structural diagram which explains the operation, where you can see that the architecture involves the two input variables speed error E and change of speed error DE. These variables were calculated using the equations, like the mathematical equations which are shown in the slide at the specific sampling times. So the two input variables speed error E and the change of speed error DE, they are multiplied by the scaling factors K1 and K2 respectively, and the calculation is done according to the equations, and the controller's output is then multiplied by the another scaling factor K3 to get over the final output. The choice of appropriate scaling factor values is critical as they significantly impact the performance of the fuzzy logic controller. So the parameters that has been discussed in the mathematical equations are quite clear in the structural diagram of this fuzzy logic controller block diagram. As you can see here, the parameters K1 and K2 are mentioned, and how the input is then processed in the fuzzy logic controller, and finally the scaling factor K3 is multiplied to reduce the error and get a proper output from the fuzzy logic controller.
Hi everyone, my name is Mohammed Sajid Akhtar. Now we come across the fuzzy base wind turbine control which we are going to implement in this project. Uh, for this fuzzy control, we have taken the input variable as a dV and dP. that is delta voltage and delta power, and the output variable is delta voltage. Here we can see that we have implemented 25 rules and inferences. Actually, inferences and rules of the fuzzy logics are the, you can say, it's a definition or a logical if then statement which we can implement in the fuzzy control. Here this logic has been created like when the dv is nb, that is negative big, and the dp is negative big, then the output, that is dv, is positive small. Like that, total 25 rules are implemented in this fuzzy control. Now we have performed 3 different cases, and after that we have compared the performance of that cases. The first case is the MATLAB simulation of wind energy conversion system, that is a wind turbine without any maximum power point tracking. The second case is the with MPPT, which is controlled by the PID, and third case the MPPT, which is based on the fuzzy logic. So we can go one by one. Here is the MATLAB simulation model which has been created without MPPT. Here you can see the components. This is a wind turbine, this is a permanent magnet synchronous generator, this is a AC to DC converter, then DC to DC boost converter, and then it's a load. Now this is a graphical representation of the input of the wind turbine, which is obviously the wind speed. The normative wind speed for this wind turbine has been taken as a 12 meter per second, but for the simulation we have varied this wind speed from 8 meter per second to the 12 meter per second. You can see first it was 10 meter, then 12, then 8, and we can check the performance of the wind turbine and the other component as well as the wind speed will change. This is, you can see there is no MPPT pulse. That means this the first case is the simulation which is without MPPT. This is the output voltage. You can see that is output voltage which is which varies from 160 volt to 260 volt as per the wind speed changes, and accordingly this is the power output which varies from 330 watt to the 800 watt according to the input of which is obviously the wind speed. Now the second case, it's the simulation model. Here you can see all things are same, only the changes we have made that there is a PI controller based MPPT which trigger the gate of the DC to DC boost converter. Accordingly the voltage and power will affected. Here the wind speed we kept same as earlier, that is it varies from 8 meter per second to 12 meter per second. And this you can see the MPPT pulse which has been generated by the PI controller according to the requirement or according to the algorithm. And this is the voltage output we get by this type of case, that is which is the PID based MPPT. And here we can see the voltage varies from 160 volt to 280 volt. Now we come across our final part, that is the simulation, which is based on the fuzzy logic control with MPPT. Here we can see there, instead of the PI controller, we have implement a fuzzy logic controller, and it provides a pulse width modulation signal as a pulse to the same gate of DC to DC boost converter. The same wind speed varies from 8 to 12 meter per second, and here you can see that this is a fuzzy logic MPPT pulse, which obviously differs from the PI based MPPT pulse. Here the voltage output we will get from this simulation, and it varies from 170 volt to 280 volt. Accordingly, this is the power output, which varies 400 watt to 990 watt. Now we come across a comparison between all three cases. This graph shows a comparison of the MPPT pulse of all three cases. The blue line shows where the no MPPT pulse is there. This green line shows the pulse which is based on the PID controller, and all the red lines pulse shows the MPPT pulse which is due to the fuzzy based controller. Here there is a comparison of the voltage, output voltage. The red line is the fuzzy based controller voltage output, and obviously we can see it is better, it is more than the other two controller output. Accordingly, power is also maximized with the help of fuzzy logic controller due to the variation of the wind speed. It is clear from this graph.